Part F, find the area of the region enclosed by the graph of f and the axis. So for part F, area under our curve, and this area will be this area here, A, be the area enclosed by our curve and the x-axis. So we have to do the integral. Area under the curve always means integral between our limits on our x-axis, which is pi and 0, of our function, which is e to the x sine x in terms of x. Okay, this is a bit of a funny integral, this one, because this is actually a repeating integral. And you'll see what I mean by that. To actually integrate this, we need to use integration by parts. And integration by parts, we usually let some term equal u, and what in this case, what we'll let u is actually going to be. Let me get my correct pen. Yes, u is going to be sine x, and u dash will be cos x. V dash needs to be in this original integral, which was just e to the x, and v will also be e to the x, the integral. So the way we solve this is going to be formula uv, so u times v, it's going to be e to the x sine x, and we'll have our limits of pi and 0 minus the integral between our same limits of pi and 0 of v u dash, which is e to the x cos x dx. So this is integration by parts. If you've forgotten the formula, it's the integral of u v dash equals uv minus the integral of v u dash. Now, notice that we're going to have to integrate this as well. This is also an integration by parts, because we can't integrate this into a simple term just yet. So this will equal, I'm going to leave in e to the x sine x here, of pi and 0 minus. Now the integral of this one here, I'm going to let u equal cos x, u dash equal negative sine x, v dash equal e to the x, and v equal e to the x. And I'm going to get the integral of e to the x cos x. This is going to be uv, so I'm going to put a big bracket here. uv, so e to the x cos x with our limits of pi and 0 minus the integral of v u dash. So this will actually turn to plus, with minus minus, plus e to the x sine x dx. And let's close our big integral. So this is what the integral of pi and 0 e to the x sine x dx is. Now there's a reason why this is called a repeating integral, because this seems like it will go on forever. We're going to have to keep using integral signs, but there is a way that we can actually kind of get to our answer here. It's a bit of a neat way. If we open up this big brackets, this will turn negative and this will turn negative. If I add this negative term of the integral of e to the x sine x dx over on the other side, I already have one of them. So there's actually going to be two of them. There's two integrals from pi to 0 of e to the x sine x dx will equal e to the x sine x between pi and 0 minus e to the x cos x between pi and 0, and this was negative, so we added it over. So we actually now can just divide by 2, and we have our answer. So this is kind of neat. It's a pretty cool way of doing this. So if I sub in pi and 0, I'm going to get e to the pi sine pi, which is e to the pi, and then sine pi is 0, minus e to the 0 sine 0, which is just 0, this is actually going to be 0 minus 0. And then minus e to the pi cos pi. Now cos pi is -1. Minus e to the 0 times cos of 0, which is 1. And this is what 2 integral is. So this will equal 0 minus, now e to the pi times -1 will be negative e to the pi, and then we have minus 1. So this will equal negative negative, so positive e to the pi plus 1, and that's what 2 times our integral was, e to the x sine x dx. So finally, the integral between pi and 0 of e to the x sine x dx, we can just divide this 2 underneath. We're going to get e to the pi plus 1 over 2. Okay, long question, but we finally got our answer.